we have ourselves some pizzas. They're perfectly split into 3. They're great. Awesome. Cool. These are all the exact same size. This one has 1 piece left. This one has 2 pieces left. And I want to know if I can fit them in one box. So I'm going to add them up, correct? So this one is 1 out of 3, because I'm pretending it's the same sizes. They're just terribly off. And then this one is 2 out of 4 slices left, right? How can I actually put them together? You have to get a common denominator, because you have to cut them into the same amount of pieces, right? Yeah, totally. So this one I would multiply by 4. This one I would multiply by 3. So this would be 4 out of 12 pieces. And then this would be 6 out of 12 pieces. Right? Yes or no? Yeah? And if you don't know, this one would be split into 4. All of these. And then these would each be split into 3. Because if I split these into 3, I have 12 pieces, right? I split those into 4, I have 12 pieces. We agree? So this one is the same as 4 out of 12 pieces. This is the same as 6 out of 12. Which gets me how much? How many pieces? 10 out of 12. Now what happens with you guys is you guys will make common denominators and then add the denominator. I'm like, what was the point? Why did you make them both 12 and then made it 24? Like, why would you do that, right? So we keep that same amount because that's what it's out of. The top is how many you actually have. The bottom is what it's out of. Now, what it's out of doesn't change. Now I can tell you that these would actually fit in 1 pizza box, correct? All those pieces would fit in 1 pizza box because they'd be 10 out of 12 pieces, and I fit in 1. Looking at it this way, it's a little bit harder to decide. All right. So in order to simplify addition and subtraction of rationals, I need common denominators. Now I'm starting off with common denominators. You're not going to get ones with common denominators on a test. But we start off with them to figure out how to deal with it. So here, do I have any non-permissible values? Is there any variables in the denominator? No. So I have no non-permissible values. Now does this question have an equal sign in it?
No.
No, so it's an expression. So if it's an expression, I run the equal sign down the left-hand side and just keep going. This equals an x, equals an x, equals an x. So make sure you have equal signs. Everything we've dealt with so far has been a simplifying expression. So we've ran equal signs down the side, whether it was a simplify, multiply, or divide, always equal signs down the left-hand side. Okay, so now these are both over 3. So I can write it all over 3, correct? Because they both have the same denominator, just like I wrote that last one all over 12. And then we put our top together. So we get 2x minus x. What is 2x minus 1x? Yeah, so just x over 3. And I have no MPVs. That's it. Wouldn't it be nice if we just gave you common denominator all the time without MPVs? Be great. So B, we have a common denominator of what? 5. So we put an equal sign down the left-hand side, and they're all over 5. Now I have to do the numerator. So I get 2a minus 3 plus 9a plus 1. It's all over 5. What do I get in the numerator? 2a plus 9a is 11a, because we collect like terms. And then plus or minus 3 plus 1, negative 2. Are there any MPVs? Can I take anything out of the top, a GCF, or make it simpler?
No.
No. So I just box it. You guys try C and D. So this is over 3x over 4 plus x over 4. So I'm going to get a denominator of 4. And then on the top I get 3x plus 1x, which is how many x's? 4x over 4. Is 4, now some people say, can I cancel the 4's off? You can if they're monomials. Is the 4 and the x a monomial? Is there any plus or minus signs between them? No, so they're monomials. And so is this. So can I cross the 4's off? Yes. So my answer is just x with no MPVs because I didn't have a variable in my denominator. Now watch D. D gets done wrong a whole bunch of times. Paying attention? So when it's an addition sign, people will often do well. When there's a subtraction sign and then a binomial follows it, so if you look, we have 5y minus 1 over 6 minus 4y plus 7 over 6. Do you see how there's a 4y plus 7 after that minus sign? So there's a binomial. You have to remember to subtract the whole binomial. So if you only subtract the 4y and not the 7, the answer will be there and it will be wrong. So remember, you have to subtract everything behind the subtraction sign. So these are both over 6, so I can write them all over 6. And then I get 5y minus 1. And then I have to subtract the 4y, and I have to subtract the 7. So I get minus 4y minus 7. So you collect like terms, it's all over 6. So we get 5y minus 4y is what? Y. And then minus 1 minus 7 is minus 8. The answer to you forgetting to subtract that 7 and going minus 1 plus 7 and putting a 6 will be there, and it will be wrong. Okay. What's up with example 2 now? Different denominators, but still no non-permissible values. The denominators still on this one don't have letters, don't have variables, correct? So still no NPVs. But I can't put 4 and 3 together because they're different. It's like example 2, the left-hand side's out of 4 slices, the right-hand side's out of 3 slices. I can't put them together, correct? But what common denominator can I make between 4 and 3? 12. So what I do the bottom to make this common, I have to also do the top. I do the bottom here is 4. I have to do the top because I can't just multiply the denominator by something random and not do it to the top. I'll change my fraction completely. And then I run an equal sign down the left-hand side. So I'm going to get, guys, I'm going to get 3x times 3, which is 9x over 12 minus x times 4 is 4x over 12. Now we're back to where we started in the previous example, right? Common denominators. So now that we have a common denominator, we can put them all over 12. And I get 9x minus 4x. What's 9x minus 4x? 5x over 12. And nothing can cancel. When we're looking at B, B has a, yeah?
What happens to the x's if it's 9x minus 4x?
It's like treating the x's like they're apples or xylophones, let's say. I have 9 xylophones, I subtract 4 xylophones, I still have 5 xylophones,
yeah.
not 5. Yeah. So division would get rid of the x, but everyone will honestly try and drop off the x's. We just have to watch ourselves because when we're collecting like terms, I literally treat them like xylophones and like yaks. Or whatever the letter is, I make them be that. 10 apples minus 6 apples so that I keep the apple.
Yeah.
Yeah. Okay, so B has a denominator of 3 and a denominator of 6. What can I make them both be? 6. Remember, you can't make them be smaller. You'd have to make it be bigger, right? Because when you make common denominators, you multiply, you don't divide. So I'm going to multiply this one by 2, the whole bracket, and this one by 2. So what am I going to get here? I'm going to get 3a times 6, oh my gosh, 3a times 2 is 6a, minus 1 times 2 is minus 2, all over 6, plus 4a plus 5, all over 6. Okay, now I'm just back to where I was in the previous example, right? They're both over 6. So now I just go 6a minus 2 plus 4a plus 5 all over 6. Now because I have the variable a, I treat them like apples. Yeah. So here I have 6 apples, you could do avocados, okay. 6 apples plus 4 apples is 10 apples. And then negative 2 something plus 5 of something is 3. All over 6. Is there any NPVs I can take or GCFs I can take out or anything like that? So this is a binomial. Good question. So that top is a binomial, correct? That numerator? It's 10a plus 3. And how can we cross off binomials? With only binomial, the matching binomial. So can this 3 and this 6 cancel, which a lot of people do? No. Now if it was 10a times 3, then you could, with a multiplication. Good question, because lots of people will cancel that out. Okay, you guys are trying C. So, I know, listening, if I give a question like this without a common denominator and with a binomial following behind a subtraction sign, that's going to be your ugliest question that I can hand you. Because not only do you have to figure out what the common denominator is and make the common denominator, right, Merrick? You're going to have to then remember to subtract all of the terms behind the subtraction sign. So there's lots of places to make oopsies. So between 8 and 3, you guys were discussing this, it's 24. So I have to multiply the numerator by 3 on the left and the numerator by 8 on the right to make that 24. So I have to do that first. The people who try and do this in like 1 step or less will make oopsies. Please, don't waste your, if there were a time to waste pencil, it would be on a test. Use your pencil, okay? I have extras, you can even borrow. All right. So 8y times 3 is 24y. Negative 3 times 3 is negative 9 over 24 minus 2y times 8 is 16y. Guys, please don't make me compete. My voice is going again. 1 times 8 is 8 over 24. So once I get my common denominator, then I can write it all over 1, right? That's the point of getting the common denominator, not now writing it over 48. Because what was the point of getting a common denominator if you don't use it, right? So we're going to get 24 in the denominator, and in the top we get 24y minus 9, and then I have to subtract all the terms behind the subtraction sign. So I'm going to subtract 16y, and then I'm going to subtract a positive 8. Then I collect like terms. So now it's y, so I'm going to use yaks. 24 yaks, subtract 16 yaks is 8 yaks. And then negative 9 something minus 8 more of that something is negative 17 something. Now to get yourself to not cancel stuff off, please watch, because a lot of people get here and then they wreck it. It's really beautiful and then you just destroy it. The 8y minus 17 is a binomial, correct?
Yeah.
Does it need to have brackets? No. But does putting brackets around it maybe cause you to not take the 8 and the 24 and cancel them off? Sure. Why can the 8 and the 24 not cancel? Because it needs to be a matching binomial to cancel binomial, and that needs to be a monomial if you're going to cancel those, which you can't. So that's as good as it gets. Do I have to put the brackets in the numerator? Like if they don't put the brackets, do I not circle that answer? No, you don't need the brackets. It's just proving that it's a binomial. Okay, flipping over. Yeah, so, guys, what's the difference between this page and the common denominator questions from example 1? This one has non-permissible values, NPVs. That's it. Okay? So I want you to try A, B, C, and D. You just have a catch. You have to state non-permissible values. So these are all over X. We agree? So our first step is to get common denominators. Everyone puts their phones away. First step is to get common denominators. Next step is to put your numerators all over it. Then we collect like terms. So we get 2 plus 7 is 9 minus 1 is 8. But we have to follow behind with X can't equal 0 because we have non-permissible values here, right? And non-permissible values are always stated before you cancel. The next one I have 2a. Both of them are 2a, which is a monomial. So a 2 and an a, if you want to, you can put them in their own brackets because it's a monomial, correct? Or no brackets at all, it would be totally fine. So on the top, I get 5a plus 3 plus a minus 6 Because it's A, I will use avocados because I was using apples earlier and they wanted avocados. 5 avocados plus 1 avocado is 6 avocados. Then 3 something minus 6 somethings is negative 3 over 2A. Guys, is there anything I can do with that top? So can I cross the 2A and the 6A off? Can I do that? No, because 6A minus 3 is a binomial. We agree? But can I do something to that binomial? What can I do? Take out a 3. So I have 3, and then I'm left with 2A minus 1 over 2A. Can the 2A's cancel now? No, because the 3 is the only monomial, and 2 and A are monomials. So monomials can cross off monomials, and binomials can cross off binomials, correct? So are there any monomials that can cancel here? No. So really, I like this answer, and this answer is fine, but the way it'll look on the test is 3 bracket 2A minus 1 over 2A, and then they'll say A can't equal 0. So they just won't put those extra brackets around the monomial, but there's nothing wrong if you do, but the multiple choice will not have those extra brackets, okay? So don't be like, it's not the same. Okay, this one here, we have 3y minus 1 is my common denominator. On the top, I get 3y minus 1. Wait a second. They match. What do I have to do before they match? NPVs. So I have 3y minus 1 can't equal 0. 3y can't equal 1. So y can't equal a third. So my restrictions or my non-permissible values. And then these cancel off. These slanted lines, these canceling lines, what are they actually? Just what? They're just ones. So this is technically 1 over 1, which is not 0. What's 1 over 1? 1. So I go 1, and then I go y can't equal a third. And this one, we just have to watch that subtraction, because there's a binomial behind it, and the subtraction has to go to both things. So we're left with x plus 3 in the denominator, common. And then we get 4x plus 10 minus 2x minus 4. So we get 4x, 4 xylophones minus 2 xylophones is 2 xylophones. And then 10 of something minus 4 of something is 6 over x plus 3. Can I do anything else? Can I cross off the x's? Can I cross off the 6's? Can I cross off the 6 and the 3? Can I cancel all those things off? Just like go willy-nilly and cross things off randomly like I feel? No, the top is a binomial, the bottom is a binomial. Do they match?
No.
Can I do something to the numerator?
Yeah.
I can take out a 2. Then I'm left with x plus 3 over x plus 3. Now these cancel. But before they cancel, I have to do what? Yeah, so x can't equal negative 3. So I get 2, semicolon, x can't equal negative 3. Okay? What do you suppose I'm going to have to do here? Get common denominators. These both have a p in it. So I need to add an extra p? No, I just need to multiply this one by 7 and this one by 3, and then I'm left with 21p on both of them, correct? So I want you to try A and B.
For one.